Okay, for part two of Adobe Flash Objects, we're going to be looking at objects today. In this session, continuing on with with our last section, we're going to go ahead and move forward. And I want to just make a quick comment to let you know that this is a big unit, and it really is more of a reference unit. So I really can't apologize the fact that there's just a lot of stuff to learn, and I'm trying to make it as exciting for you as possible. And it is the heartbeat of what we do in coding. But it goes without saying, if I didn't cover all this stuff, we wouldn't really know how to code very well. So let's get to it. Okay, so we were just wrapped up talking about various objects, and we've been talking about instance core objects. We talked about the arguments object, the array object, and now it's time to take a look at the Boolean object, which is a wrapper for the Boolean primitive type. It defines no properties, only has two methods. The methods are the toString and value of, and we'll do a couple of examples of each. I want to make a point, though, to point out that to be careful not to confuse objects and functions. Here's an example for where you have a variable and you assign a value of true to x, and we go b equals Boolean x. Well, this script creates a primitive Boolean named b, but it doesn't create a Boolean wrapper object. So in other words, there is no new keyword. So the call to the conversion function Boolean has nothing to do with this Boolean wrapper object. So here's an example that indicates this correct script for this creating this Boolean wrapper object. And you can see it starts off where we have the variable x is equal to true. But the difference, the primary difference in this one is that we're using, in this example, the new keyword. So the new keyword creates this Boolean wrapper. Okay? Notice that x is our constructor. All right? And b is our reference. So there's some methods assigned to this as well. Here's a method that's called the toString method with Boolean, and then you can see that it returns a string containing either true or false depending on the value contained by that Boolean object. So it's best shown with an example. Go ahead and type this example up in Flash right now. Okay, so let's take a look at this, a little closer look on this toString method. First, what's happening is that we're creating a new object reference, which is b, right? There's our object reference. And we're assigning it a new Boolean instance that is initialized to a value of true. So here's the new instance, and that's our initial value of our Boolean, right? Then when we trace it out, our expected trace statement is true, and that's indeed what we got. Now, when I use the type of method, the type of method is used, remember that's the other method in the Boolean object, so I'm tracing the type of b, and it returns that, hey, this is an object type, okay? Now look at we go further into our example here. We're looking at we have an s variable is equal to our object b dot, and then I'm applying the toString method on that object, right? Then I want to trace out s, which is b toString, and then I use the type of operator for our trace statement on s. And we can see that it is actually a string variable type. Okay? So it's probably a good example of how we use both of these methods in ActionScript code. Okay, so the next object that we're going to look at is an object that is used quite often or quite frequently, and that's the number object. The number object wraps the primitive number type just like the Boolean wrapper for Boolean primitive variables. But in addition to the two methods and one property present on Boolean, the number object defines several more properties. So we'll take a look at some of these properties. The first one we want to look at, if we can get over, is the max value property. It's kind of interesting to see that the max value that you can store in Flash, or it can be represented in Flash, is this number here in scientific notation. I'm not even begin to even try to say how big that number is, but you can see a scientific notation. It comes out by this number followed by 294 zeros. That's a pretty darn big number, right? And then if we were to go further on this, and let's look at another property, what would be called the infinity constant. Okay, so a lot of times we think of infinity like who is that, Buzz Lightyear, that says to infinity and beyond, something like that. Well, in Flash and coding, infinity is actually a number, and it recognizes infinity as a number, and you can do that with this example. So you can type this in Flash. Go ahead and do that right now. If you're with me, make sure you pause it if you need to pause it, but go ahead and type in trace type of infinity, okay, and show me what your result will be. So as you can see, when you type this in Flash, trace type of infinity, the return is actually number. And so if I compile it and run it out, you'll see that indeed, yeah, it is a number. So Flash recognizes infinity as a number. Another way to refer to the value of infinity is to use the property number dot positive infinity. So there are two versions in Flash for the same number because of infinity, because the value of infinity came before ActionScript actually became an OOP language defined by the ECMA 262 code, so or standard. So in any case, you can just, this example just drives that home. Okay, so you can put this example in as well. Don't put that negative sign in there. That's just a bullet. Sorry, I apologize for having that there, but trace number dot positive underscore infinity. If you do that now, you'll see that it does return the exact same result. So here's an example where we have trace number dot using the positive underscore infinity, and you can see that the result is the exact same as our previous example. Another property that we have is the number.minValue property. It's similar to the max value property, except that it defines the smallest number that can be represented in Flash. In other words, the number that would be closest to 0 on our numbered line. So the actual value is shown in scientific notation here. In other words, it's a large number as well. And again, it's about 300 zeros. So it's a very, very tiny number. Okay, and so Flash can store large numbers and tiny numbers as well. Okay. Here's a negative infinity, which is really similar to the positive infinity. And if you type in this trace statement out, we can go trace number dot negative underscore infinity, and you can see what the result would be with that as well. It should show like negative infinity. Let's take a look and see if that does. Yeah, after running the negative number dot negative infinity, you do see exactly it does run a negative infinity. So that's pretty cool. So let's discuss the string object. This is the final wrapper class that we really have to discuss in ActionScript, and that is the string wrapper. It wraps, as you might guess, a string primitive. Okay, it works just like a number in Boolean. The single property that string defines is called length, and so the length of the string. So the string object defines several methods for us, and we could take a look at every one, but that would take us quite a bit of time. So probably the best thing to do is just put it into a table, and which we've done here. So we can see the name of the method and a description for each one. We can cover a few of these, or you can skip ahead or skip around on this video to see which ones that you may want to look at and use and learn more about. But in any case, this table is probably the most important thing because it gives you a reference for all these various methods. We can take a look, for example, at the string char@, method. It's logical to think about a string as an array of characters, really. That's what they really are. Strings contain, you see, a contiguous block of variables. You know what I mean by contiguous string? That sounds like a big word, but contiguous is just everything lined up in a row, right? One after the other. So it contains this contiguous block of variables. All strings are indexed from 0 to length -1. So it's a pretty extensive amount of numbering system that we have there. The char@, method works by accepting an index as an argument and returning the character that exists in that index location. The syntax is listed at the bottom of this slide, and it's always best to see it with an example. So go ahead and put this example into Flash right now and see what you come up with. So after typing that into Flash, let's go ahead and compile it or run it and see what happens. Let's create our Swift file. And wow, look what happens. We've got the word hello in a laid out with each letter and stacked on top of each other. So let's take a look at how this worked. All right, so as you can see, we first created a new string named S and hand the string hello to the constructor. Then we loop using S's length property as our loop index. And inside the loop, we trace one character, the one at the loop index position. And then this essentially just prints the string vertically in the output window with one character on each line. Pretty cool, huh? If I go ahead and compile it again, you'll see how it works. So let's break this down a little bit. So let's take a look at this, the string.charCodeAt method, right? This function returns a 16-bit representation of the character at any given index. String.charCodeAt works like char@, except that instead of giving you a string with a character inside it, charCodeAt gives you a number with the ASCII representation of that particular character. So the ASCII number that represents that particular character. All right? So we can test this out by just adding this script in our action script. Let's go ahead and do that right now and run it and see what happens. So each of these numbers represent the position of each character in our ASCII character table. So this would be H, this is E, here are the two L's, and here's our O. Pretty nifty, huh? Okay, another method we have here is a string from charCode method. And this function is not called on an instance of a string object. Instead, this one's called on a global string object. Here's the syntax, and here's an example at the bottom. Go ahead and try this out and see what happens. Notice from this time, we're putting the ASCII numeric representation of each character that we want to be traced out. Give that a go and see what happens. We'll jump to Flash to see. There it is. And we'll go ahead and compile it and let it run out. And so here's another way of tracing out the word hello, just by the ASCII representation. Here's another method that's called the string.concat method. And best shown really with just an example, so I'm jumping right into it. We've already seen a concat method with used with arrays. This one's really no different. It works by just accepting a second string as its argument and then copying that argument onto the end of the first string. So anyway, the newly created strings then return. So note that the original string here is ineffective. It's not a destructive thing. Also note that this method can take more than one argument. So you can use concat to form a string from any number of other strings. And this example should actually demonstrate that. So let's jump over to Flash and see how that works for us. So here's the example where we have we're tracing out s.concat on t. We're concatenating s and t, so we've got hello world. Okay, s being hello and world being t. All right, but they're both new objects, right? And so is m. I've got a new object, and the new object in m says, Mom, I'm home. So if I start playing around with it a little bit, I can say trace s.concat, and then I can concat mt, mt, ss, and our result is this, which is kind of fun. Okay? Hopefully that all worked out for you. The next method that we're using is the string.indexOf method. What this does basically searches a string for a specified substring. So an index is given and the search begins at that point. So it returns the index of the first occurrence of the substring, number myString.indexOf, substring, start index. Okay, so let's go ahead, and I've got 3 examples that you can go ahead and put into Flash right now to see what the result would be. Again, an example works best in this case. Okay, so let's take a look at each of these to try to figure out what happened here. In the first case, the output is 6, okay, on our first trace statement. And you might want to think, well, hey, why did that happen? And it is because the string's index begins at 0. Remember, it always begins at 0. And the substring world first occurs at the 7th character, or index 6. See, 0 through 6, right? 6 would be the 7th character because we have to count 0. So look at the second example and see what happens. We ended up with 12. So scripts outputs 12 because the search doesn't begin until index 3, which means that the first occurrence of world is skipped and the first occurrence after the starting index is at the 13th character, or 13th character would be 12, right? And then finally, with the last example, we can see where this substring doesn't exist in the string. So in other words, this example, the substring Fred actually does not exist in the original string. So the number -1 is going to be returned in our trace statement. Okay. Okay, then we have a method called the last index of method, and really this is the same as index of method, except that it searches a string for a substring and it returns the index of that last occurrence. So we should be able to do this example. There's actually two examples that I have in this method. The second example shows how the method works backward on a string. So if you specify a starting index, it begins at that index and searches towards the beginning of the string. So go ahead and put in both of these methods, and let's check it out. So you can see in the first case, in this the index of method rather, the output is 12 again, but this time you see there's no starting index. Because this method returns the index of the last instance, the second world string starting index is returned. And so if the substring doesn't exist, then -1 would be returned, right? So another thing to note is that this method works backward on the string. So if you specify a start index, it begins at that index and searches toward the beginning of the string. So we may actually want to see that with an example as well. Okay, let's take a look at this example right here on 2. So it says s equals new string high, trace s dot last index of high, comma 5. The output here is shown to be, if we were to compile it, is shown to be actually 3. And so you're thinking like, okay, well, what happened here? Well, it's because of the following. The second argument, the starting index is 5. So Flash begins looking for the last index before that index. So it moves left and then it finds what's the second instance of the high substring in the original string high. Okay? And that has a starting index of 3. Okay, I know this can be somewhat confusing. It's kind of like working trial and error type of thing. So you just kind of have to get a little bit creative and make up some examples on your own and play with it and get comfortable with it. Okay, so another method that we have available for us dealing with strings is the slice method. Let me jump back to our PowerPoint presentation here to show you this method. Bring it up. So this is one of the many methods that deals with parts of strings. It says the syntax is string myString dot slice start and end. It returns a string, requires one argument, but it can take 2 optionally. And so here's an example that you can go ahead and put in Flash. And then there's a second example as well. So go ahead and take a moment and write this code up into your Flash environment. So you can imagine this is one of the methods one of the several methods that are available for dealing with parts of strings. And so when you're doing text processing, sometimes it's very, very common to extract parts of these strings. So, Flash has all these different types of methods available to us. And then many of these methods do similar things, but have different arguments for our convenience. So, there's subtle differences here. So we can look at each one individually, and you can cover, like say, go through them really quickly if you'd like. This is a string slice method with 2 examples. This first function that we're looking at is called just simply slice. Okay, and as you can see, this method returns a string. It requires one argument, can take 2. First is starting index to begin slicing. The second optional argument is the ending index for the slice. So if you don't supply the second argument, slice just will continue all the way to the end of that string, and this example drives that home. So you can see from the output that this first slice starts at index 6, and then it goes until the end of the string, and then the second slice starts at index 6 but stops at 11, index 11. So notice that the 11th location contains a comma in the original string, but the comma is not printed in the output. And the reason for that is because slice will stop just before the ending index. And then the third call, our third trace statement here, reverses the arguments and puts a higher index first, which causes that output to be blank. So that's the intended behavior for the slice. And you may be thinking, hey, I'm wasting my breath telling you about it, but hey, some of the other methods behave differently that'll have a major difference with this method. So just keep that in mind. Okay, and the other example that I have here, and we should probably go over this, and it's like if you use a negative number for one or both of the arguments, you get behavior demonstrated by this script. All right, so you can see in the output that a negative argument causes slice to count from the end of the string and not from the beginning. And that will work with either argument or both. But the second example, where the first argument is negative and the second is positive, is an unusual search, and it's normally not done, even though technically it's possible. So hopefully you kind of enjoy these examples. Our next example we're going to look at is the string substring method. Let's take a look at that. So this method is almost identical to slice. The difference is that instead of taking an ending index as its second argument, substra takes a length. So here's the syntax: string my string substra, start, and then length. Go ahead and put in this example into Flash, and let's take a look at the outcome. Let me comment this one out. And looks like I need to put this one in, so I'll type it in myself. So here we put it up in Flash. One thing that you may, if you're copying and pasting from the slides, you probably figured this out already, but I just wanted to remind you that sometimes your code won't work, but you just have to put in the change the quotation marks from the PDF files or the PowerPoint slides as needed. So so this is the output that we're getting from this. The string substra, let's try to take a look at it and see what's happening here. It's almost identical to slice. The difference, of course, is that instead of taking an ending index in the second argument, substra takes a length. And so this is an example shows that the second parameter is optional. So substra goes into the end of the string. If we look at this one, there's a lot going on actually with this little bit of code. First, notice that the third call to substra, that's this one here, okay? This is using a negative second argument. So we've got a positive 6 as the first argument and a negative 2 as the second argument, okay? In slice, that causes Flash to index from the end of the string and not the beginning, but in substra, because the second argument is a length or number of character to grab, a negative value results in an empty string, and you can see that, okay? And also, the fourth call to substr uses a negative first argument, but that works. So the reason why it works is because the first argument is an index and it's not a length. So flash will index from the end of the string. So when we run this or compile it, you'll see that we have an empty or a blank line, and then we have, but the difference is because of the argument is an index and not a length in the first case. Okay? Okay, so here's one that is called substring. And I know what you're thinking. Yeah, this sounds very similar to substr, but it's it's probably the name is too similar. But substring is just in its name is similar, but here's the form. If you look at string mystring.substring from and to. Now the way this method works is a little tricky here. So I'm going to try to go through this kind of slowly. So the method gives you a substring as a return value, and the arguments are indexes. The first argument, from, represents the beginning index to grab from. And now if this first argument is negative, 0 would be used, and the second, an optional argument, is called to, and that would indicate the index of the character just prior to the end of the substring. So if this argument is negative, 0 is used. And finally, if the first argument is less than the second argument, then the numbers are automatically swapped before the method's going to be executed. So let's look at some examples to see if we can drive this whole concept home with substring. So here's an example utilizing substrings method. Go ahead and enter this into Flash right now, and we'll talk about it. So let's go ahead and compile this one and take a look at it once we've got this written in. You'll notice, though, that the output is shown here at the top of this screen. But look at line 5. We look at line 5. You can see that this is a little bit different here because you see both of these arguments are negative. It's -6 and -2. And so in this case, since they're both negative, Flash will use 0 for both of those. And so in this case, because the arguments are equal, and an empty substring is required. So that's exactly what happened. Okay, so this next method, the string split method, it's not used very often, but you may need to use it once in a while. Here's a syntax where we have the array mystring.split. You've got a delimiter, and then of course a limit. So the first thing to notice here is that the function returns an array, not a string or a number. The second thing is there are two arguments, one that's required, and then one, of course, that would be optional, indicated with those braces or those brackets. The function works like this. First of all, the split method returns an array of substrings. It creates the substrings by breaking up the string object based on some character it uses as a breakpoint or delimiter. The second argument, limit, is used to limit the number of substrings that are extracted and placed into the array. So the function split is essentially the opposite of join. It'll take an array and make a string by placing a specified string between each element of the array. So split takes away a specified string and uses it as a separator for producing an array. Now these two are often used together even though they're logically parts of different objects. So let's go ahead and take a look at split in action. So here I've got a split method here. Let's go ahead and compile it. And you can see that we have a string um, with S. It says, hello world, I'm happy to be here. And we're splitting it out on the first array and tracing it out and splitting the second one through my array 3 and my array 4 occasionally, and then tracing out the output. So we can take a look and see what's happening. In this example, these 4 arrays are used by calling split several times on the string object. Then we're using the toString method of the array objects to output the values in each array so that you can see what's in them. So the output of this script can be seen right here on the output window within Flash. You want to notice first of all that the first split uses the string quote with a space, okay, as the delimiter. What this does is it causes the array to contain substrings that are broken off from the main string by the space character. The space is still a character, even though you don't see it, right? The second split calls the same delimiter, but this time imposes a limit of 2 with the second argument, and the third split uses the delimiter string O to break up the string. So then the final split uses the delimiting string happy. So that's a wrap for today, or for this section, this part in our process of learning about objects. I know that's fairly lengthy, and we still have actually quite a ways to go, and as you can well imagine. And so this is I don't want these any one of these videos to go too terribly long, so so that you can take a break, get up, get some coffee, or a glass of milk and cookies, whatever. Okay, so that'll be a wrap for today. And like I say, we will definitely jump into more of our lessons here. I just didn't want this to run too long. I think we made some great progress today. So take a break, go like I mentioned, stretch your legs or whatever, and we'll jump back into it when you feel a little more comfortable to do so. There's still a lot to go here with this whole section in objects. I know for sure, I'm going to continue to listen to old Dropkick Murphy. I think I'm addicted. Yeah, I am addicted for sure. So I'll get them to rock and roll right now. Till next time.